So, just like we've done in the past two topics, the one-way between and one-way and factorial between, let's talk about this sort of digression into a different way of looking at the sums of squares, these computational sums of squares, right? So again, I want to point out this is an alternative approach. It's not required that you know this. It's not required that you memorize these or learn these equations, but I do this for two reasons. One, a lot of people, when they go through the prereqs of this course, have learned it this way. So just to make sure that there's some continuity between the way you learned it in your previous course and now. And two, it is a time-saving approach that if you're working on an exam or something like that, especially when there's a time crunch, doing it this way can actually save you some time as opposed to doing all those sort of deviations. And this may also be less sort of error prone, since with the deviation approach, you're trying to sum up all those deviations and squares and stuff like that. You're more prone to mistakes. So here's a time saving, but not necessarily, it doesn't really explain what the sum of squares are and what they're doing, so it's not very definitional, it's not very intuitive of why we're doing it this way, but it does get you to the answers much faster. Okay, so as you look here, you can see the scores pre-post follow-up are the same. It's just instead of looking at the subject means, I now have subject sums. So this is the sum of 15, 13, and 16 for subject number 1 all the way down. I have the sums of each group, pre-post follow-up. I also have the sum of y squared, which is 15 squared plus 20 squared plus 14 squared for all 30 scores. It's the sum of y squared, that 8271 number over there. And then I have the simple sum or total. If I add up all 15 scores, I'll get this 473 number, which is just the sum of all the scores. All right, so I need it set up in this way, or at least I need this information for me to be able to do it as these sort of computational approaches, these alternative approaches. So again, you may, you should see parallels to this. Now, one of the things that you'll notice that is a little bit different or interesting is that instead of using n, I'm using s, only because with n, we typically think of n as just the number of subjects, which it is, but here I'm using sort of s to mean the same thing, but also because s is its own effect. Sum of squares for subject. It's really weird to just put n in here. So instead of thinking about this as the sum of aj squared over n, I'm putting s here. So s and n in this case are sort of interchangeable, but it's really the number of subjects. So you actually would get the same thing as you would if you stuck n in here. It's just when you get to here, to switch them around and say the sum of n, it seems weird to sum n. They're not really summing n, we're summing each of the subject scores, which is why I sort of switched out n for s, which I understand can be confusing, but hopefully this will make it a little bit clearer as we go through it. So the first equation is the same as this for between groups. The sum of aj squared over the number of how many scores did it take to get that sum in there? That's what you're going to divide it by. T squared over total n. All the number of participants times the number of times that they were repeated is sort of a by s. Okay. For subject, it's the sum for each subject squared and then summed over all the subjects over the number of levels of a. Okay. T squared again over total n, a by s. For error, you got the sum of y squared minus what you already found, the sum of aj squared, minus the sum of si squared over a, and then plus t squared over as. And then total is the same as the sum of y squared minus t squared over as, or t squared over big N. Okay, so let's see how we plug numbers into those. So, all right, so for between groups, it's the sum of AJ squared. So where are the sums of AJ? All right, so this is essentially A1, A2, A3. I need the sums of each of those. I need to square those sums, and then I need to add them up. All right, so we can do that. So starting up here, I need the sum of A1. So the sum of A1 is 175 squared plus sum of A2, which is the post, is 139 squared. And I need the sum of A3, which is the follow-up, of 159. Take all that, and I'm going to divide by the number of participants. So each one, we're adding up 10 things, so I'm dividing here by 10. All right, so let's do that. Oh, and I forget, I got to subtract out t squared, 473 squared over a times s, which is our s is 10 times 3, so this is divided by 30, or like big N. Okay, so let's subtract those two, equals. All right, so 175 squared plus 139 squared plus 159 squared equals 75,227. So the top part of this is 75,227 divided by 10, which is 7,522. So this is 7,522.7 minus 473 squared is 223,729 minus, so that divided by 30 equals 7,457.633. So I should be able to subtract those. 7522.7 minus 7457.633 equals 65.067. 65.067. All right. So far, so good. So here, the sum of SI squared. All right, so SI is now all these, the individual subject sums. And so there are 10 of those. All right, so I'm going to start those down here. So it means I need 44, 52, 34, 59, 56, 59, 56, 71, 52, 34, 23, 48. I get all of them. 2, 4, 6, 8, 10. Looks like it. So all of these are squared, and we're adding them all up. Right? And all that divided by the number of levels of A. All right, so the levels of A are, well, there are 3 of them, so we divide this by 3. And then subtract from this that t squared over as that's right here. We already know that. That's 7457 minus 7457.633. I already know that part. I already did it. All right, so let's do all the squaring. So we got 44 squared plus 52 4 squared plus 52 squared plus 34 squared plus 59 squared plus 56 squared plus 71 squared plus 52 squared plus 34 squared plus 23 squared plus 48 squared plus equals, divided by 3, no, divided by 2. Alright, I screwed something up. 44 squared plus 2 squared plus 34 squared plus 9 squared plus 6. Alright, if you square all this up, divide by 3, you get 8049 minus 7457.633 equals, let's see, that minus 7457.633 equals 591.367. Alright, so far so good. The next one, sum of y squared minus the sum of AJ squared minus the sum of SI squared, and then plus this again. We have a lot of repeats, and the sum of y squared is given to us. So this one, we don't really have to do any more computations except to subtract and add. So sum of y squared is 8271 minus. So this is the sum of AJ squared over S. So minus 7522.7. Okay. And you subtract out the sum of SI squared, which is this 8049. Now you add back the t squared over AS, which is this 457.633 number, which equals. So we subtract all that out. $8271 minus 7522.7 minus 804. Crap, that's a problem. 8271 minus 7522.7 minus 8049 plus 7457.633 equals 156.933. Error. And then total down here at the bottom is, again, the sum of y squared, which is 8271 minus our t squared over AS, which is 7457.633 equals. Let's see, 8271 minus 7457.633 equals 813.367. Let's see, does that all match? So going back here, we said before subject was 591, but we subtracted, and I already forgot. But let's look back at some of the other ones. Subject is 591.367, that works. Between group 65.067, that works. Error we found, but we didn't. So we've said that was 748.3 minus 591.367. 0.367 equals 156.933, which is that's there. All right, and then total we found before 813.367. All right, so everything looks good, and it all matches up to the deviation sum of squares. So that's it. That's the computational, or this sort of alternative forms of sum of squares for the repeated measures, ANOVA.